Hello, everyone. My name is Michael Pardue. I am a senior software engineer here at Accusoft, and I'd like to thank all of you for coming out here to listen to me talk about miscellaneous things. So I'm the senior software engineer, and I'm also the chief T-Rex artist, like some of you know from the last session. And I drew a special one for today. Yes, so he's building a frame. It's a good little T-Rex. We don't know how it's working because his arms are too short. So this is about inversion of control, but I'd like to start with the reasons why we want inversion of control, and that is with separation of concerns. So with regards to inversion of control and dependency injection, the object construction and the usage with the logic tends to get intermingled. And if everything's all bundled up together, then you have a lot of issues trying to separate, code for tests, trying to separate the logic out so you can move it somewhere else so that you can use different services with the same logic and stuff like that. So it's important to be able to separate the construction of the objects from the actual code. It makes maintenance and changes to the code a lot more difficult, and when code is responsible for multiple jobs, it's much more difficult to test. So I've created a couple of examples to kind of walk through the difficulties in the code. So here's some, sorry. Okay, can everyone see that?
Yes.
All right, okay, so this is just a simple little mock-up. I'm creating an instance of a service. I'm going to get data from it, and then I'm going to display the data that I've returned from it. And here I have created the database connection in the constructor. And that makes sense. I'm creating an instance of the service. The connection is associated with the service, so clearly I need to have that connection instantiated within the service. But unfortunately, because it's within the constructor of the service, now it is directly tied to the execution of the service. And so when you want to do anything with this service code, you have to have that database connection. And so now if you want to test the code and you don't really want to test against your database, now you have to mock up the database somehow, and you have to try to mock up that external resource, and that's going to make things really difficult. So another option is to try to inject the database connection. So let's see what that looks like. Now the service has been decoupled from the database connection. It's just expecting a connection to have been passed in that's going to have a certain interface to it, with duck typing, and it will allow for the service to be used in a number of different situations. And this now allows us to create an instance of the service in a manner that allows for us to write unit tests, because now we can create our own mock of the database connection. We don't have to worry about trying to mock up an external resource while trying to run tests. And this allows for the test to run a lot quicker and a lot simpler. However, the important thing to take from this is that, say this is application code, so ignore the definitions of the classes. Now your application has to know how to create the database connection. It has to know how to create an instance of the service, and if you add additional things to the service parameters, so like you have a config or you have another service that you have to call, then you have to make sure that you are injecting those services or the configs or all the objects in the constructor everywhere you call the new service. And so that means that now your application, while you've kind of made your service definition declarative, it's still imperative how you go about instantiating your objects. Your application has to fully understand the reasons why you have to instantiate these additional objects, why you have to inject them. So that's why we like inversion of control and dependency injection. So let's move on to that. All right, so classically the program makes calls into the libraries like what I just showed you. But the inversion in the inversion of control is that the framework is what's making the calls into the libraries. So your logic only simply has to say, hey, I need to have this service. I only need to have this database connection. I don't need to know the inner workings of it. I don't need to know the config stuff. I just need to know that I need to have a connection. And so you request to the framework, please give me this connection. So dependency injection is just a very specific form of the inversion of control, where when you're creating the objects, you are passing in the dependencies of that object. So this is also referred to as services and clients. So your client is what has the dependencies, and the services are what you're trying to inject into there. And the injection usually occurs during the construction, but sometimes your framework will pass it through properties. It just depends. And so there's a few major patterns. There's the factory pattern and the container pattern. They're kind of simple, but what the factory pattern does is it says, I'm going to create this object based upon the type you have given to me. Whereas containers say, I'm going to manage this set of objects, and you may request an object from it. And so the way that the factory works is you just pass in the type, and it determines from that type that you passed in what dependencies need to be instantiated. So if it's already instantiated some of the instances and those instances have been marked as singletons, then it'll just go ahead and pass in the ones that are cached. Otherwise, it's going to pass in the ones that it needs to create. And so it can take a little bit of time for it to do that because it has to walk through the tree of the dependencies for the instance. Because if you have another object that depends on another object, then it has to go through the construction of those further down the tree. Okay, so I created a small sample of what a factory would look like, an implementation of it. So we have this, and I'm going to actually have a factory object create the instance. And I just wanted to kind of walk through how an example of one of these factories would work so that you can think about it as we're going deeper into inversion of control and dependency injection. All right, so we still have the same objects, but I've added a little bit of code here where I'm marking this as a required dependency. So I'm just saying that service requires objects of type DB connection to be injected into the service. So when the framework comes and instantiates this, it's going to say, okay, I have this requires list. Okay, I'm going to walk through this requires list, and I'm going to generate the appropriate parameterization to instantiate the service on behalf of you as the caller. All right, so this little factory object, it's just going to take a set of services that have been defined. So the types. So you can see here, I'm just passing the function name, and that's referring to the actual function definition, and so that's the actual type. And it's just building a little dictionary. So now, when I create an instance, I'm going to pass in the type of this class that I want to create. And it's just going to take a string, so I've totally decoupled from the actual implementation of the class, the service class. And I can now ask the factory to go and find the interface that is associated with it and create an instance. So it'll walk through here, and it goes into the services dictionary, and it returns the object associated with it. And then it will check to see if there's any requires. And so here, this is just a little trick to say if I haven't defined any requires, then return an empty array, so that when I try to walk over the requires, I can just return an empty array and create the instance without any parameterization. And then this goes through each of the requires and then calls back into the factory and requests the instance for the dependency that I need to create the instance that has been requested by the caller. So this goes back into the services. So for a service, it says, I need this DB connection. So it goes back in recursively into the create instance and creates an instance of the DB connection, which then I am putting into an array, and then through some JavaScript magic, I am binding the array into the constructor for the service class. And so that allows for me to create an instance. But the idea here is that I am walking through the tree of dependencies. So if I wanted to create another dependency that DB connection has, so like this, I can now go here and say DB connection. And when this goes to instantiate a service, it will walk through and it will generate this MySQL first, and then it will generate the DB connection, and then it will generate the service. And so that's how the dependency trees work, and that's usually what happens when you have a dependency injection or IOC framework creating an instance for you. And so, like I said, factories tend to have a container within them that gives them just a little information about the dependencies and kind of manages all the dependencies for you and may drive the factory. All right. And so another thing about the separation of concerns is that you get object reference decoupling. So you don't care about the actual implementation. You're only wanting to have the object defined by the interface. And now you don't really have to be concerned about the concrete class, the full implementation. You want the framework doing that work for you. You want it to be declarative how the classes are structured. You want it to be declarative when you're creating an instance of the class, so that it's that much easier for you to take that declarative state and put it into another state so you can use it somewhere else. That gives you greater composability. It makes testing easier, and it makes maintaining your stuff a little bit easier. So there's a few Node.js libraries that already exist. Some of you may have heard of Electrolyte or Inversify. I'm going to dive into Electrolyte a little bit. Inversify has some really neat implications, but it's making use of other languages on top of JavaScript, specifically TypeScript, which gives you more information about types. But Electrolyte keeps it more towards native JavaScript, which means that it's a little easier for you to consume in your libraries. You don't have to change the structure of your application to use a different language. So Electrolyte works by adding annotations to your object. So you have a file, and in that file you modify the exports object with annotations that indicate whether or not it's a singleton and whether or not it's it has any requires. I'd like to go ahead and define singleton right now. Within IOC containers, basically there's two modes that you have when you're instantiating the objects. The singleton states that this object is only going to be instantiated once, and so every object that consumes that singleton will always use that same object. But it's not like a static class. It's being managed by the framework and not by the runtime. Otherwise, it just always instantiates a new object specific to the instantiation of the dependent that you are creating. So this is the syntax, and it's basically just a string value added to the exports. And when you want to get one of these components, you request it through its IOC container. So I have an example using Electrolyte. All right, so this is an example service object. It's just going to say hello world, and I put it into a promise because it's in a service, so it looks asynchronous. I have it marked as a singleton because it's only going to be instantiated once, and everything that uses it will always use the same instance. This is the client that's going to consume it. You can see here in its constructor, if you want to call it that, it's taking the service as a parameter, and then it gives you access to the service so that you can pull the data from the service. And here we've marked in the require annotation that we need the service. And so what Electrolyte is going to do, it's going to associate this string with the file name. So it's going to look in wherever you've defined to Electrolyte where the files are that map to this value. So it's going to look for this service.js, and then whatever's consuming client is going to look for this client.js, and it's just adding the .js for you. So this is the application that's actually driving it, and I'm going to require Electrolyte. It gives me the IOC. I tell it to look in this components folder, which I've put here, and then I'm going to create an instance of the client. And I'm going to run it. And you see it gives me hello world. It's very simple, and it's giving you a dependency injection within Node.js. Let me get back to the slide. But there are some weaknesses with it. First off, we're using non-standard syntax. So if we go back into here, we've had to create some annotations which aren't normal for Node. This is not standard behavior, and it doesn't look like anything that we have in JavaScript. The object instantiation is synchronous. Now, that kind of makes sense because object instantiation, we're just constructing that instance. But what happens if when we're creating components that are more complex than simply objects? What if they need to get information that has an external resource? What if we don't want the object, what if we don't want what's using it to know that it needs to initialize a connection or do something to that effect? In applications, when we're trying to get the architecture together, we want everything that's consuming it to see the simplest form of the interface. And when there are asynchronous things that need to occur while you're trying to get the component set up for everything, then this is going to make some of that more complex for the client code. And the other issue is that the main entry point must be defined. And my grammar failed. So that's supposed to be and managed by the app. So basically what I mean by this is that when you start up the application needs to know what objects it's going to initialize at the very beginning. If there's multiple objects that it needs to request from the container, it needs to do that. And that has to be defined. And every time you make changes to the application, that has to be updated within the entry point as well. And so it means that you have multiple places within your application that needs to change beyond simply just referencing the library that you're now incorporating. So I'm introducing a Node module that we're creating here at Accusoft called Framing, and we're going to be releasing this as open source within the next few weeks. I'm not totally certain how many weeks a few weeks is, but it's within the next few weeks, sometime within at least before September 15th.
What license are you releasing?
We don't know exactly which one yet. That's part of the reason why it hasn't been open sourced yet. What framing is a simple way to organize an application into components. I wanted to take that beyond simply organizing your objects into components within an IOC container. It's dividing your application into discrete components in such a manner that your application can be declarative. The component initialization then is decoupled from the application logic. So beyond simply just saying request this object, that's handled by framing now. And it requires minimal changes to your node modules. I mean, how you generally create the node modules with the module.exports and whatnot, that can all stay the same, but it requires just simply to add a new method and some metadata information to your package.json. All right, so why did we go with framing?
Michael needs a new lexical parser.
The IOC dependency injection libraries for Node.js did not really handle application flow. And we needed a flexible framework for building an application divided into discrete components. And why is it flexible? Well, after you've created the components for framing, they don't have to be used by framing. They can still be used in any other context. Generally, there are a few components that I've created that require like built-in framework information just to like take advantage of being within the framework architecture, but that's not necessary for all framing components. The wire up for the components exists outside of the JavaScript code itself, which means that your JavaScript code remains, nearly pure JavaScript, and you don't see any additional annotations that aren't specific to JavaScript, and you don't see anything that's foreign when you're looking at it. It all looks like pure Node.js JavaScript code. And so because we use node modules as our components, not simply files or classes, they can be as complicated as necessary. You can have like a full application built in a node in a framing component, and then simply combine that with another application, and you can get some composability that goes beyond simply just objects. So I wanted to dive into application components a little bit. I really want to drive that this is declarative application architecture. So it's beyond simply the normal IOC declarative architecture. You declare the required components within the application, how you're importing the NPM modules into it. And then when framing starts, it builds a dependency tree from all the components that have been pulled in. And so when it creates the dependency tree, it gives you the option to execute it, or you can just hold on to and do what you want. But when it initializes, it's going to do all that up front. And so now your application is done, and it's just going to run like a normal Node.js application, but you don't have to worry about the performance hit later on for pulling another object outside of the container or the factory, because all that work's already been done at the beginning. Also, it allows for asynchronous instantiation. Since we're building a whole dependency tree and we're walking through all the objects, we really want to make sure that as it's executing, it's doing everything safely and appropriately. So it does it in the right order, and it does it without needing to worry about whether or not one object is going to stomp on the other object. So I want to show you a little bit of code, because this asynchronous instantiation is actually where we divide, where we break from other IOC containers like Electrolyte. Okay, so I have another example here called async error example for Electrolyte. And basically, the only difference is that now it's actually going to pull from a service. I want to take a moment. When this happens, like, it's kind of bad practice for objects to do anything with an external resource in the constructor. That's like what everybody has always said not to do. It makes your constructor unsafe. But we're talking about application architecture, where we're trying to build up the initial state of the application. And so you have to do that at some point. And you need to be able to coordinate that initialization. And so if you can't do it in the constructor, then you have to know that this object requires initialization, and then you have to coordinate the initialization within your application logic itself. And so this version of the service for Electrolyte is going to attempt to pull the data, but if the data is not there yet, then it's not going to work. Yeah, the data was not retrieved. So it didn't have enough time to let the set timeout to complete, because it was 250 milliseconds and Node is relatively quick. And so it was going to fail really no matter what. So I'm going to show you a framing example now that's not going to be affected by this. And then we'll dive into how to actually build a framing application in a little bit. All right, so basically we have the initialize function, and it's going to, wait, I'm sorry. We have the initialize function, and it's going to pull the data using the same promise here and the set timeout, and it's going to wait 250 milliseconds. It's going to, once it gets the data, it's going to let that promise return another object with an interface. And so this gives us the interface into the component. But now this interface is representing an object that has all the data already hydrated within it. And so when the client calls the service and it calls get data, that's going to work appropriately. Yay. It succeeded, or I'm lying to you guys. But it was able to wait the 250 milliseconds. Let me change the time so that it waits like a second so we can actually see it. Okay, so it waited a whole second, and it allowed for the application to get all the data that was necessary, allowed the architecture to do what it needed to do, and now the application is executing in a known and desired state, and none of the components really have to worry about coordinating with each other because framing is already performing that coordination for you. So if the asynchronous component errors, then framing is going to deal with it for you. And it's going to stop the application, and it's going to give you a report of the errors that have occurred. Another thing that it does, besides just handle asynchronous initialization, it handles parallel component initialization. Some of the dependencies are going to be called in such a manner that there's going to be an actual tree with a number of leaves. And it's going to allow framing is going to allow those to run in parallel together, and it does optimizations to attempt to get that as flat as possible in terms of what components are actually executing. And so while those are running in parallel, the dependence of those parallel initializing dependencies will block until the dependencies have all been satisfied for it, and then those will go, and those will continue up the tree until the dependency tree has completed. Right, so basically if you have multiple components in your application that all need to make database calls or make some sort of long-running call to get the system up and running, maybe it needs to make a licensing call or something else. This gives you a chance to do several of those in parallel without having to really try to coordinate with each other that, hey, the application is up and running and ready to go. Multiple main entry points. I told you that the application says, with the IOC with like Electrolyte, you have to say, okay, I need this component to be initialized, I need this component to be initialized, okay, run the application. With framing, it allows for you to basically just say, okay, this component and this component need to be started. And it could possibly be that you have two dependency trees that are totally separate and distinct, and it'll walk through all those for you. Or it'll attempt to merge them for you, and it will walk up the merged dependency tree up until it gets finally to the root nodes at the very top of the tree. And so what it means is that components really are getting initialized at the same time without any concern about whether or not they know about each other. And then the application gets to not have to worry about coordinating that effort. All right, so now we're going to get into building a component. All right, the first thing that you have to do is create a node module. I mean, we open up a folder, we type npm init in the console, and we write what we need to write. And then we add a framing property to the package.json. So what this framing property is, it's just a little bit of metadata that indicates to the framing component, node module, that the application is reading in a component that is a framing component. And then it gives you the opportunity to add additional information, like setting up what dependencies you require, and additionally give you the option to associate a different name with your component. So you can have a type of interface name for your component that's decoupled from the name. And then you have to add an initialize function to the main file. So in the package.json, you indicate what the main file is within the, and that main file needs to have an initialize function because that's the interface for Framing to be able to state, okay, give me your object, give me your totally initialized object. It can go into any folder. So I said a node module, but you don't have to use a node module. You can create a components folder if you don't really want to deal with the overhead of getting your node module into npm or into your local repository. All right, so what that looks like, so we have the name, and you can see here that the name does not have to be the exact same as the name of the package. So this is the framing name, and then this is the imports, and this is how we indicate what dependencies are required by the component. All right, now the initialize function. There's two mechanisms that you can do this through. You can either return a promise, and so you can make use of newer promise code, or if it doesn't make sense for what you're doing, you can still use a callback. It doesn't matter which way you go, you don't really want to cross the streams on that one, and you want to make sure that you're only using one form. The other thing about this is that this is also a mechanism for returning an error. So in the callback, you can see it's taking the normal callback structure for any node modules, and you pass the error through the callback. And same with the promise. If you reject in it, that returns back, and that allows Framing to know that whatever you're doing asynchronously has failed, and that gives Framing a chance to stop the application and report the error to the console. If you throw an error within the initialize, that's okay. But what you're returning back when you're resolving or you're calling the callback, that is the interface now to your object. And since we're in JavaScript, we don't actually have like a pure interface, but we can do what's called duck typing, and basically, if it looks like a duck, then it is a duck. So if it has the method you're expecting, then you do what you need to do with it. All right, and so if you want to start an application, you want to set the base directory to Framing, and that just gives it a chance to say, okay, this is where the current working directory actually is, so that it can go and try finding the node modules. It can try looking for any additional pathing, and it gives you the opportunity to start the application in somewhere totally bizarre, or it gives you total flexibility in terms of how you want to actually structure your application. Maybe this JavaScript file is deep within your repository, and then you just execute the run method. And when it executes the run method, that's what prompts Framing to build the dependency tree, walk through the dependency tree, build up an initialization plan that basically says, okay, I can run these in parallel, I can run these in parallel, I can run these in parallel, and move forward. All right, so just to fall back to how to show an error, you can throw an error just like this, and this allows for Framing to immediately catch it. But again, if you have anything asynchronous, that's going to react a little poorly. And so you want to make sure that you are popping it up. And so when Framing shows the initialization errors, it's going to build you a report, and it'll indicate which components have failed. So you aren't trying to traverse through the files and trying to figure out what has failed. It'll give you an opportunity to really understand which one has failed. And so it'll make sure that the error stack is returned, which component, which version of the interface, etc. So I have a little example of that so that you can see the report. So I built a component over here, and all it's going to do is throw errors. And then this is just going to look for it. All right, so I've npm installed it by passing, you can npm install by passing a folder path. And so this is just how I'm getting the component into it. But I could also have told it to look in the components folder and find all the components in there. And the other thing to take note I'm not telling it to run any specific component. I'm not telling it to pull from anywhere. It's just looking through the dependency tree, and it's trying to figure out what it can start and what it can do. Right. All right, so this is the error report that it shows. You can see that I have created an interface called SomeComponent, and so that's the name in the framing property of the package.json. This is the name of the node module that it was in, and so it's identifying to you that there was a little bit of a discrepancy there to help you identify where the code is. And then it just shows you the error message and then the error report. So you have the stack trace, you have everything you need to fully debug where everything's failing. And so if multiple components throw errors, which is possible since they're running in parallel, this gives you the opportunity to view that report and fully understand what has failed. All right, so to import components, you want to modify the imports array in the package.json, and you are just specifying it by name. So I showed you this here where there's the discrepancy, this name here and this name here for the package.json. You can call by either one of these. And so if you use this name here, then it's going to look for the node module that's implementing with this name, or it's going to look for a node module that has framing set to this name. Otherwise, if you pull this one, it's just going to look for that name, and then it's only going to use the node module. So it's just so that you have an opportunity to have multiple node modules with the same name, with the same framing name. And so this gives you the opportunity to install the components into the component folders and to install within the application package. You can choose either way. That's how you get the node module into the application. And then just to reiterate again, this is how you identify the node modules by the name. So both of these will be the same if they return the same interface. Otherwise, there's going to be some crashing code when it's calling the framing node module that doesn't have the appropriate interface. But as long as you know that the interface has remained the same and that the framing name is the same, you can alternate with whatever components you want to. So this gives you an option to like make a mocking node module if you need to, or if you want to try to just change it for production or for dev. It gives you a number of options that allow for you to do what you need to do.
Mike, quick question. If you throw because the interface is wonky or incorrect, you're calling the wrong one, what's the stack look like for that?
That would be in your actual components
Okay.
code. So it depends on how it crashes, really. So if it crashes in a manner that it's still synchronous, then it'll just bubble up the stack, and that error message will show during initialization. But that error is probably going to manifest later in the application code. Once the initialization process of the framing is completed, then all the components have already gone outside of the framing context. Framing is no longer managing the application state for you. You're just within your application code. And so that error is probably going to have to be handled by your code. It depends on where you're using it. If you use it in the initialize, then that's going to bubble up as saying like method is undefined, or maybe the parameterization is not right and some argument exception falls through. But that's only going to happen if you used it within the initialize function. All right, so I have an example application that I'd like to walk through that kind of shows how we would add additional components to a framing application. So it's just a simple express hello world application. So I have all the node modules already there. They're just not simply installed. And so the service is the actual application. And right now it's set up to import the server and the client. And the server, as you can see here, has dependencies on Express and Express session and a cookie parser and I'm just trying to build up, you know, a basic Express server that I can do things with. Okay, and so it's going to listen on port 8080, and I am very creative with my secret codes for the cookie parsing. But what it's going to do is when this server is initialized, it's going to return an object that makes available middleware that we want to make available to the whole application. We want to make available the HTTP server so that we can do special stuff on the actual server object. This is the Express server application, and this is the Express session object. And so all this is doing when I initialize the server, so I'm creating the server instance, and I'm getting the port listening on, and I'm setting up all the usings and all this other business. All it's doing is just setting up Express. That is all that it's done, and that's all that it's focused on, and that's its only concern. It's not actually setting up any routes. It's not doing any of that. But I've exposed the application so that when I go to the client here, and I consume the server object, so I'm pulling it out of the imports. This allows for me to set up the routing. But since it's totally removed from the server object, that means that I can do this a number of different times. I can set up routes for different sections of the website in totally different components. And that's okay, and that's totally safe, because the server object will definitely be alive and ready to go when I'm initializing any of the route handling components. And so all this one is doing is just setting up a little index.html, and I'm just setting up a little message for it to render in the view just to show that Express is doing miscellaneous things. And the index.html is here, and so it's going to take the message and it's going to render it. So we'll go to the website. Yeah. All right. And it's running, and it shows hello world, and everything is super awesome. But say we want to add a WebSocket chat server to it. Like, how much effort is that going to be? Well, all we have to do is start adding additional components, and this server object doesn't have to change. So first I want to add a socket.io server module. And so all it's going to do is set up the socket. It's going to set up a channel around it. And it's going to allow for opening and closing sockets for socket.io, and it's going to handle the connection events, and it's going to handle the session for me. But that's all it's going to do. It's not actually going to do anything with it. It's just going to give me enough I'm sorry, my computer's almost running out of power. Okay. Everything is safe now. All right, so I'm dealing with the socket.io, and that's this only concern. It's not actually handling the chat. It's not handling any logic over it. And all I have to do to import it is go over here to the service, go to package.json, and say I need this dependency. And I'm going to do the same thing where I'm just referencing it by path rather than using an actual npm install. Right, and I go here and do, oh, that's the wrong terminal. Okay, so I'm installing the service object, and the real-time com object, and now the component is there and it's in the service. So I'm going to restart the service, and it didn't crash, It's still running, so everything's okay, but it's not actually accomplishing anything. So I need to enable chat. Well, I've already gone to the client code, and you can see here I'm pulling this bundle JavaScript file, and the bundle JavaScript file is pulling from this entry JavaScript. And I'm using Webpack to pull in some additional objects. So this is for client libraries, a Socket.io client and jQuery. And I'm going to try to connect to the WebSocket when it is available, and whatever messages come from the server will get projected onto the page. So to do that, I need to enable the chat node module here, component. And so to do that, again, I'm going to go back into to the package JSON. Go here, add chat. Okay, and so the chat component is there, but I need to install it. So go back to the console, npm install. It'll pull the chat. All right, so what chat is going to do, it's going to import the real-time COM, and that's going to get pulled in. And then it's going to allow for me to open up a chat namespace against the socket. And then on a connection, it's just going to say, okay, hello. And then it's going to also say that the current session has joined. And this ID is not super pretty. It's just a thing. All right, so I'm going to restart the server. And there it is. But the thing to take from all this is that it was totally separated. This is application architecture. I just added socket handling against the Express server without modifying the actual application itself. I didn't have to modify the server. I had to modify the client so that I could actually communicate with the namespace, but I didn't have to modify code that had no concern with the socket IO handling or with the application. So the application remained the same. All I had to do is just change what dependencies I was installing. And that's it. So this is framing. Let me go back here. And that's the end of my presentation.